Many games, like for example Deep.io, SwordBattle.io, and Johnny Upgrade, all have upgrade systems. It's often really tempting to max out one skill right off the bat, but first, let's take a step back and look at the math. Let's look at one specific example where you have 10 upgrade points in Deep.io, and you're looking to maximize, the keyword here is maximize, not max out, damage by bullets. In other words, we're trying to get the most damage per second, and looking at the upgrade options, it's a little tricky. Where it says bullet damage, it should really say damage per bullet, and when it says reload, we can say that means bullets per second. Let's call damage per bullet X and bullets per second Y. Even though I'm using X and Y, don't get confused and think that bullets per second is a function of damage per bullet. These are two completely different upgrades, and they're both independent variables. So if we want to find the damage per second, we can have damage per bullet and bullets per second. We can just multiply them together and bullets cancel out. So since we have X, Y, and Z, it seems really intuitive to make a nice little 3D graph here. To reiterate, both X and Y are independent variables, so every single point on the XY plane is showing us a specific combination of upgrades. Each point on the XY plane is its own input. And above each point is the Z value, which is the height, and that's going to be our output. So we're trying to maximize the height, the output, and that's equal to Z, which is damage per second. So obviously, the highest point, where Z is highest, is going to be when XY is 7, because that's where you fully maxed out damage per bullet and bullets per second. That's not helpful though, because we have a constraint. Namely, that constraint is that we only have 10 upgrade points available. So what does that mean for us? It means that X plus Y must equal 10. It means we can have 7 and 3, we can have 4 and 6, 5 and 5. It doesn't matter, but the sum has to equal 10. So let's take off the z-axis here, just look at the xy plane, and look at which points meet that criteria. Let's reiterate one final time. Each point in this graph is a specific combination of upgrades, and it's equal to the input in our 3D graph. So which points on this input plane are valid with this constraint? If we rearrange the equation a little, we can see that we can just draw a straight line. There's no fancy calculus here. This point is 7, 3, where we upgraded damage per bullet to 7 and bullets per second to 3, and this is a 0.55. These are all just the possible combinations of upgrades that are feasible with the 10 upgrade limit. So let's see where this intersects with our damage per second graph. Visually, it seems pretty clear already that the damage per second is always going to be at a maximum when damage per bullet and bullets per second are equal, when X or Y are equal. So in this case, it would be at 5.5. Let's go ahead and prove this, which is going to take a bit of calculus, but if you're convinced already, you can just skip ahead. Let's go back to the 2D graph, and since we know that the damage per second is 25, let's look at all the combinations of values that could make it 25. In other words, we're graphing the curve x times y is 25. This is called a contour of xy, it's a contour of z, and it's basically a cross-section of the 3D graph when z equals 25. So knowing that, we can actually look at the entire spectrum of contours. We're trying to find the contour that lies exactly tangent to this constraint curve, the constraint curve being that x plus y equals 10. So what does that mean? It means that we're trying to find exactly one point in common. So we're trying to find the one contour line that lies exactly tangent to this constraint curve, the constraint curve being that x plus y equals 10. What does that mean for us? It means that they're going to share exactly one point in common, which makes sense. We have to have a point that's still both valid, meaning it's on the constraint curve, it can only use 10 upgrades, and the point is the greatest damage per second it can be, so we're maximizing z. So how do we know that these two curves are lying tangent to each other? Basically, if they had the same tangent line. And we already know how to find tangent lines. It's just some basic calculus, so let's get into it. Let's start by just finding the slopes of the tangent lines, which is just a simple derivative. Our first curve is xy equals z, and this really isn't a curve, it's a surface, but we're looking at all the possible contours of the surface, which means that we're looking at something more like xy equals 25. What this means is that we can treat z as a constant, even though we know that it's actually a spectrum of values, and we're trying to find the best possible z. So if we rearrange to get y equals z over x, we can treat z as a constant and get that partial y partial x is negative z over x squared. This is called a partial derivative. And for our other line here, we know that the derivative is just the slope, negative 1. So that was nice and easy. Negative z over x squared and negative 1. Let's group together everything we know now. We know that since the tangent lines are the same, 1x from one tangent line equals 1x from the other, same with y, they're independent. So we really only need to think about the slope. So if we set them equal to each other, we can get that negative 1 equals negative z over x squared. And if we get rid of our negatives and multiply by x squared, we get z equals x squared. And then finally, we can bring back our original equations to give us some constant context about our variables here. So we know z equals xy, x plus y equals 10, and z equals x squared. And hey, just like magic, look at that. We have 3 equations and 3 unknowns, so we can really easily solve the system of equations. Substituting in x squared for z, we can get that y must equal x, and if 2x is 10, then x and y both must equal 5. So our final answer is that damage per second has to equal 5. So our final answer is that damage per bullet has to equal 5, bullets per second has to equal 5, and when we multiply them together, we get 25. So we did it! We proved here that the combination of upgrades with the maximum damage per second is 5 and 5, meaning an equal split. It doesn't matter what constraint you pick. If we say that x plus y equals 12 or equals 2, the maximum is always going to be when you get an equal split. We proved this using tangent lines. In multivariable calculus, you're going to use something else instead. You can use what are called Lagrange multipliers, which are basically the same thing, except that you use the gradients of the functions instead of the tangent lines. Gradients are vectors that show the direction of greatest increase. If you've ever used gradient descent for machine learning, that's exactly what it is. But back to gaming. This isn't to say that you should never max out any ability ever. If you think about something like Hypixel Skyblock, for example, you need to be able to have one specialty that you're able to make a lot of money in to support all your other abilities. But it becomes super important when you have a game like Johnny Upgrade. In this case, each successive upgrade becomes more and more expensive, which means that it's even more important to split all your upgrades evenly. Even so, not all statistic combinations are going to have a really nice combination like x times y. If you're looking for a holistic statistic to maximize, if you're looking to combine all of the possible upgrades in deep.io, the function is going to be way more complicated, it's going to have more variables, and it's going to include your own personal strengths and weaknesses too. So this isn't to say there's one right way to proceed with your upgrades. I'm just saying that you should think critically about them and spend every upgrade wisely. Thank you for watching. This was made with a lot of manim, which is a super cool math animation library by 3Blue1Brown and the community. Check it out if you haven't already. Make some contributions maybe. Just use it. It's super cool. I can't recommend it enough.